So the next board I'm going to work on is an old Pong looking board. It probably is Pong. It's called Spaceball. Or it has Spaceball printed on there. So I'm going to look online and see if I can get pinouts for this. And then if I can, I'll build a test fixture for it, a test harness. And looks like it's missing a switch here, and someone just jumpered. Well, I don't know if it's missing or not, but somebody, obviously that was designed for a switch, but there's no switch there, and they jumpered it. So that's probably what, the number of balls or something per game, number of points needed to win, something like that. I don't see anything obviously missing. That's broken there. So we got one potentiometer. Actually, I think they're both broken. Yeah, that one's broken too. So I need to replace both of those. That's a potentiometer too. So these two potentiometers are bad. Edge connector, I'll clean it up. I don't actually have to have the the potentiometers to get the game working. I believe that's for adjusting the paddle and stuff. Or just adjusting the paddle, I should say. So let me remove those, get those cleaned up, figure out what size potentiometers, see if I have them. I probably don't, but I'll see if I do. And it looks like something got spilled on the board there, so I need to clean that up. See what the back looks like. Not seeing anything just blaring at me. I got some stuff on the back side. I guess that's normal. I hope it is anyway. Alright, well, let me get started on this. So these are the old potentiometers. I've removed them. They're supposed to be 50Ks. So I put a couple of 50Ks in there. Not the same style, but they'll work. And I've powered it up using just 5 volts and ground. That's all I've got. I do have schematics for this if I want to wire up a connector, but for now I'm just trying to debug the basic stuff. The first thing to look at is the clock. So here's the clock circuit right there, and I need to see activity on pin 11 of E6. So E6 is A, B, C, D, E. That chip right there. Let me get my scope probe. What pin was it? E6 pin 11. Let's see what's going on. And E6. So that's 7, 8, 9, 10, 11 right there. So we've got nothing. There's E6 pin 11. It's a little noisy, but that should be a full clock signal. Let me double check. Let's see. So E6 is kind of not happening. E6 pin 11 is not happening, but let's look at pin, I can't read it, pin 3 of 6F. So right next to it, pin 3, yeah, there's nothing going on. Basically, the clock signal is not working. Let's look at that inverter circuit. So there's the phase lock loop right there. It's got a 14.31 megahertz crystal. And the inverter's on C9. Let's look at pin 10 C9, see what's going on. There should be kind of a fuzzy looking thing in the middle, floating towards the middle. C9, pin, what did I say? Pin 10. There's pin 10 right there. There's nothing going on. That oscillator's not working. So it's either the inverter, the crystal, capacitor, or resistor. So I think a common problem with these is the resistor and the capacitor is either missing or broken. There's actually two capacitors, 0.1 UF and 100 picofarad. So let me study that circuit with a voltmeter and I'll get back with you. So the two resistors in the circuit are here and here, and they both read 330 ohms, which is what the schematic suggests it should be. I looked at these two capacitors. One was supposed to be 100 nanofarads. Let me see. The bigger one is supposed to be 0.1 microfarads. That's the same thing as 100 nanofarads, and that checked out. And the other one was supposed to be 100 puff, which is the same thing as 0.1 nanofarad, and that checked out. So the only two things left is either the crystal, which I doubt it is because usually they're physically damaged and that was nice and solid, or this. And this looks a little discolored. Whenever you see a chip and the print is fading, that tells me, or should tell you, that it's getting hot and may have failed. So let me replace this first and see if we get a clock signal. So I've removed the old chip and put a socket there so I can try different technologies. I don't have an exact 7404 straight TTL device, but I do have a 74S, so a Schottky technology. I also have a 74 ALS that I can try to see if that'll work, just for fun. I know the S will probably work. I also have a 7405 in. That's the right technology, but it's an open collector. I might throw it in there just to see what it will do. I don't expect that one to work unless I add pull-up resistors, and it may not be fast enough. But anyway, so let's make sure. Let's see if the 74S is working. I've already got it turned on. What was that? Pin 11 of E6. So column E, or row E, column 6 is right here. Pin, what was it? Pin 11, so the one in the middle. All right, so there's your clock signal. We have a clock now. So let me check, let's just jump to the chase and check pin 3 and 2. Pin 2 and 3 of 6A. All right, 6A, pin 2 and 3. Sorry, you can't see that. So pin 6, 2 and 3. Oh, we got nothing. It looks like the logic, there's pin 2, it's high. Pin 3 should be opposite, and it's pin 4, invert it. So, let's look at pin 1, should be pull up to 5. Pin 1 is not pulling up to 5. It's kind of low there, isn't it? What is going on? Am I looking at the right chip? Boy, the writing is very difficult. Let me get a magnifying glass. It's very faint on that one. Oh wait, I'm on the wrong one. Was I on the wrong chip? Let me try that again. Pin 2 of 3 on pin 6. That's high. Nope. That's the right one. That chip is a... Oh, wait a minute. According to this schematic, 6... Oh, F6. Hold on. Went to the wrong place. Sorry, I thought it was an A. So F6 would be this guy here. So let's try pin 2 there. Okay, that looks better. So there's pin 2. There's pin 3. Yeah, that looks better. All right, so this circuit here is working now. We got past that first hurdle. I can almost guarantee if that circuit was bad, one of these is going to be bad. These counters like to die. So we've got horizontal generation circuit. We got the vertical cascading counters there. So I will check both of these. Basically, I'm going to jump to the chase. And let's just go straight to pin, let's start with this one. Pin 6 of 6F. Pin 6 of 6F. 6F. Pin 6, right there. So there's nothing happening there, unless, wait a minute. Pin 6 should be a signal there. Let's turn the time base. Pin 6 of 6F. Yeah, looks kind of funny to me. Hinky. Alright, that's pin 6. And pin 5 should be the opposite. Well, at least it's the opposite, so maybe that one's not bad. Let's jump to the counters. Alright, so the first one in this chain of counters is F8. Let's start with pin 8, 9, 11, 12. So 8, 9, pin 8, 9, 11, 12 of F8. F8 is here. Now see the print on that guy is faded. So it could be bad. Those are always signs that the chip has gotten hot and probably died. So there's 8. Yeah, see that's not right. 8. Yeah, 9. So this one's probably bad. Let's check the inputs. So let me speed that back up. There we go. Let's look at pin 8 at 9 again. Let's see. That was F8. 8. Oh, wait a minute. There's something there. Wait, what's going on? F8, pin 8 looks good. Pin 9, never mind, this one's looking okay. 11, 12. That looks all good to me. Well, I wonder what the hell I was looking at before. Alright, so pin 11 is used as a clock to the next one in the stage. And that's at F9. F9 is here. So pin 8 is the low counting bit. Let's see. Wait a minute. Alright, that's the first. No, wait. The first output is pin 12. Hold on. 8, 9, 10, 11, 12. Pin 12. There's nothing there. So let's look at the clock. That's pin 1. No clock. No clock B. Pin 14. Alright, so it does have an input clock on clock A. Clock B is not happening. That's because pin 12 isn't happening. So pin 12 is always low. The J input is this one. That's the J input. Oh, wait a minute. J input is nothing. Wait a minute. J input is pin 8. I'm sorry, I had it on the wrong pin. There's the J input. It's always low, and it should be a pull-up. There's a pull-up resistor on that pin. 9, 10. Pin 11 is the K input, and it's low. Pin 9 is C, which I presume is clock. Got nothing. Alright, so let's go back to F9. I am on F9. Ah, hell, I'm looking at the wrong part. Alright, well anyway, I'm having a difficulty doing this and holding the phone, so I will come back. Okay, so I tried the different chips in the clock circuit, or the oscillator circuit, and the ALS worked, the 74 ALS04, the 74 S04 works, and the 7405 does not work, which I expected. This is an open collector, so it's going to need help pulling up. It didn't work. Alright, anyway, so we have the clock. I replaced the 7493, and it was bad. We are now getting clocks. Let me just jump to the chase. So we're getting clocks. That's pin 11 there, and that's what is going to be, let's see. That pin 11 is what's going to be driving the flip-flop at 6F. So let's check pins 5 and 6 on 6F. 6F. And this is pin 5. So it's bouncing around. Pin 6. Those look really good, clean, solid signals. So all this train here, all of this clock chain is good. Let's check F7 pin 8. We should be getting something there. F7 pin 8. Let's see, F7 pin 8 is this guy. It's dead. Alright, so it ain't working. That may be bad. We have voltage on it. We have supply voltage. Pin 1 is bouncing. 2 is supposed to be pulled high. 3 is high. 4 is high. 5 should be bouncing. Then it jumps to 6 is bouncing. 8, 9, 10, 11 should be bouncing, and 12 should be bouncing. Hold on, 12. Yeah, so that chip's bad. It's a 7430. It's an 8 input NAND gate. Pin 8 should be bouncing. It is not. Alright, so I'll replace it next. It's 7430. Okay, so that chip has been replaced, but then I realized that these signals are only going to create a very small pulse. So I put the old chip back, and it was good. So I now jumped to these pins, and they're active now. They were active before, I assumed. I didn't check them. But so pin, actually I'm on the wrong one. Pin 8 and 9 of E7. Pin 8 and 9 of E7. So it's bouncing like it should, and that's invert of it. So yeah, so that whole clock chain now is good. That's for the horizontal. So now I'll look at the vertical. Let's just jump to the end here. Let's see if what is it's E7. If E7's 5 and 6 are bouncing, and it doesn't look like it is. Okay, so let's go up. Let's go backwards now. Let's look at D8 pin 8. Oh, well, yeah, D8 pin 8. D8 pin 8. It's bouncing. Okay, so we're getting output. We're getting output. No, I'm not really showing what I'm doing here. We're getting output from that chip, which is going to be the data for this one. Let's look at pin 3. Pin 3 of E7. Pin 3 of E7's bouncing. That's the clock. Pin 1 should be pulled up to high, and it is. And pin 4 should be pulled up to high, and it is. So it is not clearing, and it's not being preset. We have a clock. There's the clock, and we have data. There's the data. So the outputs, 5 and 6, should be bouncing, but they're not. So this one looks like it may be bad. Yeah. All right, so let me replace that. That is a 7474. And that's this guy. Let's see, E7, that guy right there. And it's got faded print on it, so it could be bad. So let me swap it out. Okay, so I've replaced that flip-flop, and I'm still not getting any signals on either one of these pins here. These outputs are not happening. All right. All the inputs seem reasonable and correct, so I don't know what's going on. It's almost like this does nothing. So I guess we'll move forward, but that's the only thing I see wrong with this page, and this is the clock chains, both horizontal and vertical. So pretty soon we'll be able to move forward and start trying to get video out. Let's see if there's anything else I can look at without hooking up video. Actually, I could go ahead and start looking at the video with the scope. So let's just do that and see what we get. So E4 pin 12 is the video out. So let me get my scope. E4 pin 12. Let's see. This is an 8 pin. No, 7 pin. Okay, so that's going to be pin 12 right there. So we've got video out already. So from that, I mean, from just probing without putting video to a monitor, I'm pretty much concluding that all of this stuff is working. I will put a scope to it and confirm it, but we are getting video out. So all of this stuff on this section is probably going to be okay. But that's it for tonight. I'm not going to be able to go any further on this part of the repair, but we've made good progress. Let's see what we found. 3 bad chips, and I've replaced. Wait a minute, did we find 3? We found 2 bad chips and a third one that was suspect, but I replaced it and determined later that it was okay, so I put the original back in. And then this D flip-flop that I just replaced is probably not bad. It's brand new. It's a Schottky technology, so it should be plenty fast for the circuit. But anyway, I guess next is to hook up video and see what we have. But that's it. That's going to be it for tonight, I think. See you on part 2. I didn't quit. Like I said, I wanted to probe around a little bit to try to understand what was going on. And while doing so, I found a mistake in the schematic. This was pin 1 and pin 1 on top and pin 2 on bottom, and it should be swapped, pin 2 and pin 1. So that makes a difference on what I was probing. Based on that, this thing they have marked as 4V. I'm sorry, the thing that's marked as V blank is not toggling, and it should be. And the reason is this V reset isn't happening. Man, my phone doesn't seem to be focusing worth a darn. So V reset is coming from the circuit that I replaced the D flip-flop on. And it should be toggling. It's needed for that circuit to work. We're not going to get a proper sync without it. So this V reset is coming off the flip-flop that I replaced. And we've got no activity. So this is a self-contained circuit. It doesn't require anything from outside of this circuit. I mean, the clock signal, but we know this clock signal is good. So we've got the clock signal coming in, but that's it. Everything else is feeding back into itself. We do have this reset signal though. Let me think about that. That's coming from up here, but all this stuff seems to be working. So we are getting a reset signal here. It's basically a clock linking thing. So I got to think maybe one of these counters is not counting correctly. Must have an internal problem where these aren't going sequential or something. I don't think it's going to be the flip-flop because it's a go, no-go, and it's going. So I'm leaning toward one of these having to be bad. I mean, assuming the 7474 that I put in, I put two of them in, two different ones, not counting the original, and it got the same result. So gotta wonder if it's not something to do with one of these counters. But that's where I'm at. No sync, or no usable sync. There is a sync, but it's not usable. And it's probably because this V reset signal is not working. It's just stuck high or low, I forget which. But that's what I'll be focusing on the next video.